using the quadratic formula to find the roots. By the end of this lesson, you will be able to find the roots of a quadratic function, even when you cannot factor the function. You will use the quadratic formula to find the roots. Let's start out with the do now. You are asked to graph this function. Remember, in order to graph this function, we need to create an xy table. But because I'm not given a domain, I need to figure out what the vertex is. In order to find the vertex, you should start off with your axis of symmetry formula, which is x equals negative b over 2a. But first we need to identify what a, b, and c are. Use this to get our x value for our vertex, and then use our calculator to get the rest of the table so we can plot our points. Right now would be a good time to pause the video, try this on your own. This is something you should know how to do, and then check your answers when you're done. Okay, as you can see here, a is 4, b is negative 8, c is negative 5. Using the axis of symmetry formula, we end up with x equals 1 for our x value on our vertex. I then used my calculator. I typed into y equals the equation and copied the rest of the table to include at least 7 values. It turns out that even though I've included 7 values, this ordered pair and this ordered pair will not fit on my graph, so I know that it's okay because I've indicated that this graph, this parabola, will continue to increase for its end behavior, and eventually we'll reach negative 227 and 427, but all they can show here is this. Please make sure that you have also labeled your function. Okay. Well, now down below we're asked, what are the roots? Well, the roots are always where the graph hits the x-axis. These are also my x-intercepts. It's the x value of the x-intercepts. But if I look here, my x value would be here and here, and I'm not sure exactly where they are. So technically they cannot be determined just by looking at the graph. We have other ways, but I cannot determine the x-intercepts, or the roots rather, from the graph. So let's make an estimate. This first root is definitely negative, and it's before negative 1. So I'm going to estimate that it's about negative 0.5, or negative 1/2. And for my other estimate, I would estimate, let's see, about 2.5. It could be 2.25, it could be negative 0.25. We're unsure. But based on the graph that I have drawn, those are my estimates. Based on your graph, since remember we're writing by freehand, yours might be a little bit higher or lower than mine. There is a way to find the roots, even if I can't see them on the graph. We have to use something called the quadratic formula. And we never want to forget, before we use this formula, which looks much more complicated than the one for the axis of symmetry, we need to identify a, b, and c, just like we would for the axis of symmetry. Notice x equals negative b over 2a is still there, but now we've added this extra piece on. Okay, to find the roots algebraically, we've already known that we can factor and solve. This is when we use the t-chart to get our 2 roots, or sometimes our single root. Or we could use something called the quadratic formula. Well, you might be asking yourself, how am I going to memorize or remember this formula? There is a video clip that you can use, and it will show you a song called the Quadratic Formula Song. So I'd like you to pause the video and type this address into your web browser, or you could go to the eBoard and click on the link, and you'll see a very silly song that will help you to remember this formula. Okay, now that you've listened to the very silly song, we're probably going to discuss it tomorrow in class, but let's actually find the roots of that function, the same one from our do now. This is the same function f of x as our do now. We're going to locate exactly where these roots are by using the quadratic formula. All right, alongside here, I'm going to take some notes so that you can see step by step what we are doing. And step 1 is going to be always to write the formula. So when we write the formula, we should also be sure to label what A equals, B equals, and C equals. And we'd like to do this. So our formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We want to be sure that we label what a, b, and c are as well. A is right here, 4, b is negative 8, and c is negative 5. Okay, step 2, highly recommended, is use the shell. Not sure exactly why I call it the shell, but let's set it up with parentheses. So we're going to rewrite our quadratic formula, but everywhere we see A, B, or C, we're going to replace it with an empty set of parentheses. So this says the opposite of B plus or minus, so instead of B I have an empty set, something squared minus 4 times something all over 2 times something. All right, now that's my shell. Step 3 is going to be to substitute, and we're also going to use our calculator in this step. But first, I'm going to rewrite this so that my notes are showing each step along the way, but you might end up substituting right into your original shell. You will not have to rewrite this every time, but for the first time, for notes purposes, it's nice to see each step. Okay, so our formula says that b must go here, and according to my key, b is negative 8. So I'm going to place negative 8 here. b again, according to the formula, so negative 8 should be squared. So minus 4 times a is now 4, times c, we finally get to use c, which is negative 5, all over 2 times a, I replace with 4. So far I've substituted, but I'm also going to use my calculator. I'm going to use my calculator for everything without the radical sign. So I want to clean this up a little bit, but I can only do so in stages. So I am going to choose to type only what's underneath the radical into my calculator, rather than making any silly mistakes along the way. So let's rewrite x equals, well, the opposite of negative 8 is 8, plus or minus. Now I'm going to keep this radical on my paper because all I'm going to type in is this here. So let's enter that into our calculator. In our calculator, we should enter in parentheses negative 8 squared, that represents b squared, minus 4 times 4 for a, and then in parentheses c. And if I hit enter, I end up with this expression is actually equivalent to 144 underneath the radical. Now this is all over 2 times 4, which is 8. Okay. We're now up to step 4. Step 4 is where we split apart the plus and minus sign so that we get both answers. Remember, there's always a possibility that we could have up to 2 roots. So in order to find both roots, if that's the case, I need to be sure that I always separate my answer at this step. So now I will end up with x equals 8 plus something over 8, or x equals 8 minus something over 8. And that something is the square root of 144. The square root of 144 is actually equivalent to 12. So I'm going to do 8 plus 12 divided by 8, and then I'm going to try 8 minus 12 divided by 8. My final step is to make sure that I simplify my answer. So here I end up with x equals, well, 8 plus 12 is 20 divided by 8. So that means x equals, well, 20 divided by 8 in decimal form would be equivalent to 2.5. And x here, 8 minus 12, 8 minus 12. You should always hit enter after your numerator so that you can record it. Numerator over denominator. And we know that this simplifies to be negative 1/2. So x equals negative 0.5. So now I have both my roots. There are two roots or two solutions. They are negative 0.5 and 2.5. Let's check to see if our solutions match our predictions based on our graph. If they don't match exactly, it's okay. However, they need to be very close by. So we want to see if this is actually very close to x equals negative 0.5, which it is, and x equals 2.5, which it is. So our predictions happen to be accurate and correct. Remember, use the quadratic formula song to help remember the entire formula so that you can set it up, use the shell, substitute, split apart, and simplify. We're going to practice using this formula together tomorrow in class. Thank you for watching.